So this question says, what is the pH of a solution that contains 0.5 molar, 0.45 molar acetic acid and 0.155 molar sodium acetate? The pKa of acetic acid is 4.76. So in this case, we want to use what's called the Henderson-Hasselbalch equation. The Henderson-Hasselbalch equation is basically the same as the Ka expression, except we take the log of everything and we rearrange a little bit. So what we have is pH equals pKa plus log concentration of base on the top divided by concentration of acid on the bottom. So this is the Henderson-Hasselbalch equation. Now, in this case, we could write it specifically for this case, which is pH equals pKa plus log. The base is the Ca2H3O2 minus. Remember from the previous question, the sodium is just a counter ion. Since this is minus, we need a positive ion because you have to have neutral ionic compounds. You can't have just all minus charges next to each other. So in this case, the base is NaC2H3O2 divided by the concentration of the acid, which is HC2H3O2, like so. So this is just the base and this is just the acid for this specific example. This is the generic form of the Henderson-Hasselbalch equation. So a couple things to consider before we plug some numbers in here. If we notice here, the concentration of acid is higher than the concentration of base, 0.45 molar for the acid, 0.155 molar for the base. So since the acid concentration is higher, the pH should be less than the pKa because acids bring the pH down. So it's just a good check because if you put these things upside down, you'll get the opposite answer. So if we look here, pH equals pKa, which is 4.76, plus log, the base is 0.155 molar, over the acid, which is 0.450 molar. And when you do all that math, you find that the pH is 4.30. So you'll notice the pH is less than the pKa because you have more acid in solution than you do base in solution. You'll also notice that the pH is very close to the pKa, and that's pretty normal. If you were to have 10 times more acid than base, the pH would be 1 less than the pKa. All right, and that's generally considered the effective buffer ranges. So the pH and the pKa should be close to each other for a buffer solution.